guys. Today I'm gonna move up. Yay. All right, so today we are going to be talking about simplifying monomials. It's going to be similar to what we did yesterday. So those of you guys who use photomath or weren't too sure about what to do, I need you guys to give me a little bit more feedback on how I can help you a little bit better. Email me, please. Thank you. All right, so we're going to start off really easy, guys, with even exponents. Okay, I want you to take a look at this first example. The hardest part is going to be simplifying the radical. Okay, so I have a square root of 8x to the 6th. Okay, we're going to take the square root of 8 like we did yesterday. So I could break 8 down into 4 times 2, right? And then 2's done since it's prime, but then I could break down 4 even more, right? So 2 times 2. So I have a pair of 2's and 1 left over. So this pair is going to go on the outside. This 2 is going to be left in the radical. So my final answer is 2 radical 2. Now I just have to deal with this x to the 6th. Evens are easy. All I'm going to do is I'm just going to take half of the exponent. So 6 divided by 2 is 3. So the square root of x to the 6th is x to the 3rd. That's it. And then I just have to put my two answers together. Okay, so since this is outside of the radical, it's going to go with this 2. 2 radical 3. 2x cubed radical 2. All right, let's try this one. So I could break down the square root of 54. I could do 6 times 9. You could have picked other numbers, but I just picked these. So 6 can be broken down and then to 2 times 3. So those are prime, so we're done there. 9 can be broken down to 3 times 3. So I have a pair of 3's, so that's going to go on the outside. These two don't have pairs, so they're both going to go in the radical. We're going to have to multiply them. Okay? Now, the last thing we have to do is we have to deal with this square root of x to the 8th. Again, all we're going to do is just take half of the exponent. It's half of 8, 4. So you see what I did? Just x to the 4th. And that's my final answer. That's it. Let's keep going. Ooh, gotta move again. Okay. Square root of 45x to the 12th. Okay, so 45 gets broken down into 5 times 9. And then 9 can be broken down into 3 times 3. So I have a pair of 3 and a 5 left over. So 3 is going to go in the radical. I'm sorry, 3 is going to go outside the radical. 5 is going to go in the radical. What are we going to do with the x to the 12th? Divide it by 2 and get x to the 6th. And then the 5 is left in the radical. That's it. This one, number 4. 40 can be broken down to 10 times 4. 10 can be broken down to 5 times 2. And so those are done. Those are prime. Then 4 can be broken down into 2 times 2. I have a pair of 2's right here, so that's going to go on the outside. These, both this 5 and this 2 don't have a pair, so they're going to stay in the radical. And then obviously this becomes this. So even when I have two variables, all I do is just take half of the exponent. Half of 4 is 2, half of 6 is 3. Look what I have. This 2 comes from right here. X squared, y to the 3rd, and the radical 10 goes in there. Okay. We could also have problems with many variables like this. It's not a big deal. It's just still take half of the exponent. We like this one because we like the square root of 49. Everyone should know that's 7. 7 times 7. So here's a pair of 7 goes on the outside. Half of 20 is 10, so I'm going to write a to the 10th. Half of 6 is 3, so I'm going to write b to the 3rd. And half of 12 is 6. Okay. Okay. Now, obviously, it's going to get a little bit trickier with odd exponents, but it's really not that bad. So we're going to simplify the radical again. We're going to take half of the exponent. Then, since it's odd, we're going to leave one letter or one variable underneath the radical, no matter what. No matter what odd number it is, it's always going to be left over. So 12. Let's break 12 down. So 6 times 2. And then 6 gets broken down into 3 times 2, right? Pairs of 2. So 2 goes on the outside. 3 stays in the radical. We're going to take half of 5. Half of 5, 5 divided by 2 is 2.5. So let me show you what I'm doing with the 2. So the 2 comes from this problem right over here. The 2 is right there. Square root of 3 is over here. And then since it's an odd, I'm going to have an x left over in the variable. And that's my final answer. Good. Let's try this one. This one's also nice because 25 is a perfect square. So square root of 25 is just 5. I'm going to take half of 7. Half of 7 is 3.5. So on the outside of the radical, I'm going to have 5, obviously, from the 25. And then I'm going to have x to the third. So see where I got that from? And then I'm always going to have 1 left over in the variable. Okay. All right. So I have the square root of 75. Can be broken down into 15 times 5. 5's done. 3 times 5. Pairs of 5, so 5 goes on the outside. The 3 has no pair, so it stays on the inside. I'm going to take half of 15, which is 7.5. So I'm going to have this 5. Then I'm going to have a to the 7, because that's half of 15. Then this 3 underneath the radical, and then 1 left over. Okay. Number 9. 20 can be broken down into 10 times 2. 10 then can be broken down into 5 times 2. So I have a pair of 2's. So that goes on the outside. The 5 doesn't have a pair, so it stays alone in the radical. I take half of 3 is 1.5. So I'm going to have x to the first. Half of 11 is 5.5. So I'm going to have y to the fifth. Then I have all the stuff in my radicals. I have the 5 in this radical. I'm going to have an x and a y. And that's it. Okay. Let's put it all together. Number 10 is nice because the square root of 100 is still 10. Okay, so we're definitely going to have 10. Okay, now notice here I have x to the fifth, y to the second. So the x has an odd exponent, the y has an even exponent. Not a big deal. Half of 5 is 2.5. So I'm going to have x to the second. And that means I'm going to have x in a radical later on because it's odd. I'm going to take half of 2 is 1, so I'm going to have y to the first, or you could just write y. And then I had to have the x left over because the x had an odd variable. The x had an odd exponent, so it has to be left in the radical. Okay. This one, square root of 49, we all know is 7, so that's nice. A to the third is odd, so I'm going to take half, that's 1.5, so it's a to the first, or just a. But since it's odd, I'm going to have it left over in the variable. Okay. Then we have b to the sixth. We like it because it's even, so it's just going to be b to the third. C to the fourth, again, even. And that's my final answer. Okay. One last thing I want to talk about. So, we'll do the 27 first. We could do 9 times 3, and then 9 can be broken down into 3 times 3. So I have a pair of 3's right here, so that's going to go there. And then 1 left over, 3 radical 3. Now, this is the square root of x. I can't take the square root of x because it's really x to the first. If I took half of the exponent and they get 0.5. So guess what? That means we're just going to have a square root of x. Okay? So I have it from there. I'm going to have this and that. And then I'm going to take y to the 8th. It's going to become y to the 4th. And that's it. if you guys get it.